And I'm Alvaro Velandia, and this is our project for the beam analysis coding. So here you can see our folder. We're going to go ahead and jump into it. I'm going to open up bag, which I already have opened here. So when you go ahead and you click run, it's going to start with the code, and the first GUI that's going to pop out is a welcome. Pretty much this is so that the user feels welcomed and they don't just jump straight into picking the sections. So we're going to click proceed.
Once we click proceed, you'll be able to see the different sections that are available. You have circle, rectangle, round tube, and I-beam. So we're going to select the circle. Once we select the circle, we will be inputting our values for the radius and modulus of elasticity. So we're going to say 5 and 50 for the modulus. Now we're going to click compute section. What this will do is actually compute the moment of inertia and area for that geometry, the circle geometry.
Next, you click on boundary condition, which takes you to the 4 boundary conditions that we picked for our project. The first one being cantilever, fixed end, cantilever simply supported, and simply supported beam. I'm going to go ahead and click on cantilever, and this will pop out our analysis GUI. So in this GUI, the user has a couple options. From here, he can either pick point load or uniform load, where this picture changes. So if I would go to the uniform load, picture changes, and from there, the user inputs the length of the beam. So we'll say 10 meters. The arbitrary distance, we'll also put 10 just for the sake of it, and the force 50. Now you can go ahead and click analysis, and the graphs are displayed on the right hand side. Here we have the deflection graph, bending moment, and the shear with the values of that X arbitrary location plotted on the side. If we change to point load, the graphs change, and they reflect the point load formulas that we used. So those formulas, they're coming from this code right here, good equations, and pretty much we used a switch command where we had 4 cases. Those 4 cases were for the different types of boundary conditions. So cantilever, cantilever simply supported, fixed ended, and simply supported. And within those cases, we included the if and else statements that determined if the user picked point for point load, would use this set of equations. If the user picked uniform, it would go ahead and transfer to the else statement and use this set of equations because they're different equations. And then that's pretty much it. Let me go ahead and do another example. We can go just close this, go back to bag, run it.
Now we're going to start by doing different analysis for the I-beam. So we click select. We input the values for the I-beam, the height 8, for the base is 5, thickness is 1, and modulus is 50. Compute section. Values are being shown below for the moment of inertia and the area. Now we'll click boundary conditions, and we'll determine the boundary condition for a simply supported beam. And we will do it for a uniform load, length of 10, distance of 10, and the force will be 50. Now we're going to compute the analysis, and the graphs are shown on the right hand side for deflection, bending moment, and shear force.
Now, if you remember earlier, depending on whatever load type you picked, these graphs change. So because we picked simply supported, these pictures are not the same ones as a cantilever. So these pictures change depending on the boundary condition. Just wanted to point that out. And yeah, that's pretty much it. That's our code. Thanks.